Starting a new game project is an easy but also very important step. There are things that you must do first in order to have strong foundation for the next step. In this video, I will show you what did I do to try to go in the right direction. First, I started by creating a new debug or prototype scene. I created very simple blocks and materials using this free and open source texture pack. Then, I spent a bit of time tweaking my world environment to have a better looking visual than the prototype that I've made before. I did not try to have the best possible visuals, especially with shadows, to have correct performances. I wanted to find the right balance between performances and visuals. For the moment, I will keep things simple and play more with these settings when I will have a few levels. I also imported my player scene from my previous project and it worked very easily. However, as I mentioned in my previous video, my script was a mess. I knew at this moment that I was about to split it into a finite state machine. I have also set up Git in order to push more frequently. I also cleaned my prototype level by splitting into scenes, things that I will reuse in different levels, such as the world environment for example. I also created this lightning box to see how emissive materials work in GODOT. At this moment, I was pretty happy with the visuals. I like how GODOT managed all these settings such as the glow, tone map in a single place. I also wanted to be able to toggle full screen mode using Alt plus Enter. It was very easy to do it in a script. Now, it was time to transform my player controller into a finite state machine. I watched and read a bunch of tutorials and articles about state machines in video games since it was my first one. And I started to create my state machine with the walk and idle state. I had a lot of questions such as, should I keep the input handling in both the input and process methods like I did in the previous script? And the answer that I found was both. Input is event-based, so it's better for camera movement and things that needs to react quickly. And process is more for physics things such as movement. More importantly, do I have to duplicate the code for handling the camera in every state? And how do I know if the player can move or not? Should I add a can move variable in every state? Thankfully, I found one video answering all these questions and talking about finite state machines pattern. Anyway, I started the migration of the walking state and I encountered my first issue. The walk state needs a reference to the eyes node of my player to move the camera. This makes my walk state less testable independently. The solution that I found was to decide that in the future I would have two state machines, one for the movement and one for the camera. This might be also better to avoid duplicating the code for the camera in every state. The second issue was that I needed a reference to the current velocity of the player. But this would be also not only the case for the walk state, but for every other future state. So I decided to put a reference to all these needed variables into the state machine itself. I also decided to make the state machine inherit from an interface. That way, any movement state will just need not the implementation of the state machine, but just any class that respects the contract between the interface and the state machine. That's very useful because you don't need to have a real state machine in every state, just any class that implements the interface. So any class that implements the interface can be used in a state. That way, I can easily fake some player's properties, such as the velocity for example, for some tests. At this moment, it was really hard to dig into the previous code. And I really wanted to have the same feeling of the prototype when playing. I had no clue if by pressing the forward button I would have the same velocity, I would reach the same distance and have the same acceleration than the previous script. So I decided to add something that a lot of developers don't like to do, but they are very important: test. I know that for a lot of developers it's not very important, especially when you are doing a solo project, but I really like to have some tests in my projects. And when I talk about test, I'm not talking about play test or manual test where you just click on the play button and you try your game. I am talking about automated tests. So it's important for two reasons. First, to make sure that what you do is what you expect, but also to make sure that you will not introduce a regression in the future. So that makes your projects more stable and less buggy. So yeah, it takes a lot of time to set up, however, you will gain a lot of time in the future. I did not do it in my prototype because, as its name suggests, it was a prototype. However, here, it's a real game, so let's do it. In GODOT, you have two main frameworks that allows you to create tests, GDUnit and GUT. From now, I think that GUT is the most used. However, GDUnit is also widely used, but also the only one that provides a C# support. So I installed GDUnit and most of the documentation was outdated because it was mainly in 4.2.4 and the latest version that I installed was the 4.5. For example, in the documentation, the accessor findChild is defined as not available in C#, where in fact it's totally possible to use it. But with experimentation, I was able to figure out how to use it. I tried also to debug using VS Code, but I needed the C# DevKit extension that I found terrible, unfortunately, so I decided to give a try to Rider. I might purchase it later if I decide to sell my game. Until then, I can use it for free according to their license. That being said, the tests that I added in my project were very simple. I just put it 2 players, the first one had my previous script, and the new one had the finite state machine. So to make sure that both implementations were equal, I wrote a test script that will just press the forward button and make sure that they reach the exact same distance. At this moment, I really liked how GDUnit was working, and I was pretty happy with the result. By the way, I think that GDUnit is maintained by a single guy, so if you would like to support him, please drop some stars on GitHub. Following that, I also splitted my camera logic into a state machine. For the moment, I had very simple logic for the camera, but in the future, what will differ from one to another will be the intensity of the camera shake, for example, or if I want to lock the camera on an object. So that's pretty much what I did in order to set up my GODOT project. I hope that you guys enjoyed this video and that you will subscribe to follow this journey with me.